Hello, everybody. Welcome back to the Stack Overflow podcast, a place to talk all things software and technology. I am Ben Popper, Director of Content here at Stack Overflow, joined as I often am by my wonderful colleagues and co-hosts, Cassidy Williams and Matt Kiernander. Hey, y'all.
Hello.
Hello.
So we're going to have a fun conversation today. We're chatting with a serial entrepreneur, Varun Ganapathy. He is the CTO and co-founder of a company called Akasa. He has created and sold a few other companies, and he's deep into the world of machine learning, which is involved in so much of what goes on in the software industry these days. His particular focus is trying to use it to fix healthcare, which as an American, the system has felt very broken to me for many years. So I'm interested to hear what he's trying to do.
Good to meet you, Varun.
Varun, welcome to the show.
Thanks for having me.
So we usually ask people to start off by just telling us a little bit, like how'd you get into the world of software and technology? I know for you, there was kind of an interesting overlap where you started in physics and that took you towards computer science. But maybe tell us, what was the first, programming language you did as a kid? And then walk us down that path from physics to machine learning.
I was born in India. We went to Kuwait when I was a young kid. And then when I was 4, we came to America. My dad started a computer rental company. It was called Terminal Exchange. They rent terminals, like the old school, VT100 terminals. But by that time, it was like early 90s. It obviously transitioned to renting like desktops and PCs and other types of computers. And so every time he had a computer he couldn't rent, that computer would sometimes come to the house, right? And so I would just have random computers like that would just show up. And, I was 5 or something, and I would just, start playing with them, right? Because they were there. And like, it's not like we could afford to buy those computers, but, since they were part of his business and they were just like not being used, I would get them. And what was kind of cool is they would often have software on them that like I definitely could not buy, but, would just be on them from like whoever was there before, it was like cleared out or whatever. And so I learned to use all sorts of cool programs like, I don't know, like Macromedia Director and Basic and lots of things like that. And so I started programming in Basic probably in maybe second grade. I went to the library. I remember I got a book called Basic for Kids. And I just started making little programs like quizzes or games or whatever. And my friends had Nintendo and I didn't have a Nintendo. And so one of the things that always motivated me was, man, I don't have like a Nintendo, but maybe I can just make my own games and then I can just play them and that will be fun. And so that's how I got started learning how to program. Is I just like wanted to make games. Probably that's the story for a lot of people, actually. That was just like an ongoing thing. As the internet happened, I learned how to program JavaScript. I had a few clients for web development when I was in 7th grade or whatever. So I built a few websites for people. To like, when the internet started becoming a thing.
Nice. Can I find those on the Internet Archive? Can we check out some of your work? I'll put them in the show notes.
It was for a cable company in Boston. So,
wow,
that's really funny.
Yeah.
Maybe it is on there. I can, maybe. I'll try to, it's funny. I never thought about that. I'll try to find it. I don't even know if that, maybe. I think, I remember being super fascinated about JavaScript back when I was, pretty young, and how we could do image rollovers. This is like a huge thing with Netscape Navigator. You could move your mouse over an image and it would flip over. Anyways, this was very cool back in the day. And so I learned JavaScript because I wanted to do that feature. So that was sort of like before I got to high school. And then in high school, I just, tried to be a normal like student. And, in Boston, like computers, where I went to school, computers weren't really cool. So it was just sort of a secret thing that I didn't tell anyone about. It was just my own thing. Nowadays, it's obviously much cooler to be into computers. But back then, it was like a dirty secret, basically. So then I went to Stanford University, and there I decided to I was initially double majoring in computer science and physics. But then, I was thinking about, it's weird. My feelings about computer science have been, I've been doing it programming for fun for a long time. I viewed it as a tool, but not actually as an academic discipline. It was kind of funny. I just thought it was like a thing you did to do something else. It wasn't like a purpose in and of itself. And so, and the other thing I thought, and this is kind of funny, because I've completely switched my opinion, but back then this is what I thought, is physics is real. Like the physical world is a real thing that is true, and computers are a thing humans have created, right? Like we created the languages, we created all of these constructs, and it's sort of man-made. And and that time I wasn't super sophisticated about algorithms and understanding like all the mathematics behind computers. So that's kind of what I thought at that time. So I decided I was going to really become good at physics, and I wanted to really learn about it. And I'd always been motivated by just understanding how things work. I just wanted to know how everything works, and so majored in physics. But then I started also. I was also very curious about how the human mind works and how intelligence works, and that's when I got drawn back into computer science and artificial intelligence. Because after majoring in physics, I said, I understand a lot of the physical laws of the world, but like the brain is something that we have no idea how it works and how how intelligence occurs. And so I thought maybe I should try to figure that out. Like, how do we figure out how to create intelligence? And so I started taking a lot of AI classes at Stanford. I worked with Andrew Ring. He was my first advisor in AI. When I was a junior at Stanford, he was great. There's a video he created about, he's videotaping a helicopter, and it looks like it's flying upright. And then he flips over the camera. It turns out the helicopter is actually hovering upside down. I was fortunate enough to work on that project. So I built the physics simulator for it. So this was like the bridge moment where I was like bridging from computer science into machine learning and AI. From physics to machine learning and AI. And so I built the physics simulator for that helicopter, and then we trained a reinforcement learning algorithm on the simulator. And what was really amazing is it was a summer project, Curis. It was like the summer undergraduate research project at Stanford. We just transferred the algorithm that we had trained on simulation to the real helicopter, and it worked like on the first try, which was crazy. Like that never happens. And the thing is, unlike other code, if it didn't work, it probably would have crashed, and that would have taken a long time to fix because the helicopter would have just broken. But fortunately, it worked. And we had tested it a lot in simulation beforehand. I had someone use a joystick to fly the simulated helicopter to confirm it was real. And by the way, I should mention, this is not a full-size helicopter. It's probably like 1.5 meters long.
That makes a significant difference.
Yeah, I always forget to say that. It's like a radio-controlled helicopter, not like a drone, basically, but like a very big drone, like 1.5 meters long.
Okay.
So they didn't use this for the
it sounds a lot more exciting.
Yeah.
If there was a pilot in there.
Yeah.
You were all standing right next to a big
helicopter.
Oh, yeah.
That would be much more scary. Though
much more risky.
Yes.
Yeah.
We did still stay a very long distance away from it, though, because, anything could happen, right? But that was back in 2003. And that was because before drones were, I think, a thing. I don't know. I never had seen drones commonly before that. And so that was, I think.
What year was it?
2003, the summer of 2003.
Oh, yeah, way before.
Yeah.
2013 is when DJI released their first little Phantom drone that was super easy to fly. And that's when they started taking off. So you were 10 years ahead of the curve on the consumer drones just exploding into something you might put in your backpack.
Wow. Okay. Yeah, it was definitely... It was cutting edge at the time, I thought. And what was hard about it actually was that because it was a helicopter with a single rotor, it's sort of a lot harder to actually fly than a 4-blade helicopter, because a 4-blade quadcopter, or which the drones are based on for various reasons. And so, yeah, that was a really awesome project. And then I got extremely excited about machine learning because that was really fun. I was also very happy that I could use my physics knowledge in that project, because when we were building the physics simulator, I actually could... It was interesting. I was actually able to blend ML and physics because the model was physically derived, but the parameters of the model were trained by machine learning. So it actually would use real data of the helicopter flying, and it adjusted those parameters to make the simulated helicopter behave like the real one, so that when we trained on it, it would actually be realistic. And so that was the bridge moment, just to answer your question. Sorry, this is a very long story, but that's when... And then that's when I got very excited about machine learning. I was walking down the street on University Ave, and I saw a car that said Googler on it, on the license plate. The license plate said Googler. And then I this guy came out of it, and I just walked up to him and I said, I really want to work at Google. I'm very excited about machine learning. How, can I get a job at Google? And it turned out to be Jeff Dean. And he said, sure, just email me at jeff@google.com. And I had no idea who he was or anything. And this was back in, summer of 2003. And so I just emailed him my resume. And then I got a job at Google, and I worked there the following school year. I decided that next quarter, I basically worked at Google and took classes at Stanford at the same time. But that was a really awesome project where I got way more excited about machine learning and computer science more generally. And that's sort of what started my complete switch into that and the helicopter project, and taking a class for Daphne Koller at Stanford at that time. I took this really great class called Probabilistic Graphical Models that she taught. And it was, I was taking it at the same time as I was taking statistical mechanics. And it was just so cool how the ideas from physics about entropy manifest as entropy in like the information theory sense in machine learning. And so it was like, I don't know, it was like for me, it was like a mind-blowing quarter where everything sort of came together. And I was like, oh, these Ising models we're using in physics are actually what they use to create, Markov random fields in AI. And so everything came together. And I was like, okay, cool. Like I'm going to do a PhD in artificial intelligence. And so that was sort of how I went from physics to AI.
Yeah, you stumbled upon some of the biggest names in AI. For those who don't know those names, Andrew Ng, you can find a bunch of free courses on artificial intelligence because he made them. Like he's very, very big in the AI space. Jeff Dean, I think he runs Google AI. Big deal. And then Daphne Koller, I think she works in the Stanford AI lab, and she founded Coursera.
And then also now Incitro, and also
lots of very big names to stumble upon and learn from.
Yeah, not to add the last name, I would say also very influential is during that helicopter project, we went to DC to demo it for like a grant, and Sebastian Thrun was there as well, and so that's how I started. I met him, and he was also part of the helicopter. Oh, that demo where we used the helicopter plus another robot at the same time. And that's how it became, I met him for the first time, and he and Daphne ended up being my PhD advisors at Stanford. So Sebastian Thrun, from the DARPA Grand Challenge, and he started Udacity. So yeah, I got extremely lucky to be at the right place at the right time, and just met all these awesome people and learned from them.
That's incredible. So we just did sort of this amazing collision of things where physics and machine learning came together. You happen to be in Stanford and Silicon Valley when a lot of these big names were figuring out kind of what they wanted to work on. And we were getting to that tipping point where ideas about AI that had been kind of dormant for a long time were beginning to come to life again, thanks to the amount of sort of processing power. And you went from there to create a couple of companies. Can we touch on those briefly? Like the origin of each and why you decided to sell them, I guess, and move on. And then we can transition to what you're doing these days.
Okay. So I worked at Google on the Google Print project where they were scanning all the world's books. And I used machine learning to help automate that process of reading the pages, extracting table of contents, things like that. So that got me very interested in computer vision. When I went back to Stanford to do my PhD, I focused a lot on machine learning theory and computer vision. And my PhD thesis with Daphne and Sebastian was on real-time motion capture from depth cameras. So what I wanted to build was a camera, and this is a funny story. I was like, I want to learn how to dance. So I was like, maybe I could make a computer program that would, record how people do various moves, and then teach other people how to do that because they could watch you. Sort of like Dance Dance Revolution on the Kinect way before, in 2008. And so that was my PhD thesis, was how to build that. And it was funny. When I started the project, these depth sensors cost $5,000. And so people have been trying to do things with computer vision with RGB cameras for a long time. And now it's finally working. But back then, people had just tried for a long time, and there were some limitations. Like you just couldn't break through certain boundaries. And so, there were these cameras that basically will measure not only color, but distance to an object using, time of flight. Of light. And so I used that sensor, and it was very noisy data, very low resolution, to try to build an algorithm that would in real time be able to detect a person's motion in front of a camera and use it to do other things. And so I started working on that. And as I mentioned, this was in 2009, 2008. And what happened was that essentially, I was like, I thought to myself, when I build these algorithms, eventually these sensors will become cheap, and then these algorithms will be really useful. I did not anticipate how quickly that would occur. Literally a year later, it was like 2010, the sensor went from being $5,000 to $50, like bill of materials. And then Microsoft announced they were going to use it for the Xbox Kinect to build a system that you could, interact with the computer. We decided to found a company based on the technology on how do we, commercialize it. And this is before, anything had come out yet. And so we started a company. It was called Numovis. And we started to go raise money. We went to maybe like 2 VCs, had a Series A offer. And we also had a presentation at Google where we wanted to have them be a partner. We thought, they could use this technology to power some product. And we sort of did our demo. And then at the end of the conversation, they just said, would you like to be part of Google? And,
oh, well.
And so, it was me and
do it.
Why not?
3 other founders from 3 other people from the lab. And, it was a tough decision. To answer your question, I literally was still a PhD student at Stanford, right? And I just founded the company. I think I just left or was in the boundary of leaving. And the other founders just said, let's just do this. It's like extremely low risk. Essentially we're like, it's a very big return for a very small amount of time spent. And, PhD students make $35,000 a year. And so it was quite a jump
in the
up
Bay Area.
Yeah. So it was quite a big jump in standard of living from that. And so we decided to take the offer. I was always a little conflicted, to be honest, but the other 3 people really wanted to do it. And so we did it. And so that's how that company ended up getting sold. I also started another mini company during my PhD. This was I wouldn't call it a company. It was really more of a hobby. I was really into computational photography. So a friend and I wrote an iPhone app called Pro HDR. It was, I think, one of the first, if not the first HDR app for the iPhone, or maybe it was within a month of the first app to come out. And we basically thought to ourselves, how do we take computational photography techniques and just put them onto the phone? Because now phones, cameras, and the internet had all combined into one. And so we thought we could take these algorithms that people normally have to run offline after they take the pictures and just put them on the phone. And so we built an algorithm that would take 2 pictures or 3 pictures very rapidly and then blend them together into one. It's called high dynamic range photography. And this was before it existed at all. Now it's a feature on every iPhone, and I think every Android even. But back then, this was 2009, December, 2010, it had not existed yet.
Right. So you take like 3 pictures, and the one where my eyes are open is the one you use, along with the one where my hand, looks.
Sort of, except it's for a slightly different purpose. So the purpose is, you're exactly right. And you could do that with the technology. But the general common use case is a lot of situations will have something that's very bright and then something that's a lot darker. So for instance, if you're standing in front of a sunset, the background will be a lot brighter than the foreground. And so what you can do is, what will happen normally is if you take a normal picture, you'll have to choose. You'll either say, I'm going to expose the picture such that the foreground or the darker subjects are well lit, but then you're going to have completely white-outed background. Like essentially everything that's bright will be completely no detail. It'll just be white. Or you could do the reverse. The things that are bright will be well exposed, but the things that are dark will just be you just can't see them at all. And so what it does is it just takes both of those pictures, the dark one and the light one, aligns them very rapidly together, because you're doing this with your hand moving. And that's the hard part, is your hands are moving as you take the picture. It seems like not a big deal, but the slight vibration of your hand moving will cause a lot of ghosting if you just take the 2 pictures and just directly blend them. So you align the 2 pictures very rapidly, and then you do what's called tone mapping. You basically can produce 1 pixel for every pixel in the image, where it chooses the best one. Essentially, it's it chooses the better exposed source in order to produce the result. And so it lets you actually have 1 picture that has everything well exposed. It looks a little artificial because it is, but it also, a lot of people like the effect and it looks cool. And so that's basically what HDR is, and that's what the app did back then.
Basically, every time you've tried to take a nice photo of you against the sunset, and it's either you look really nice and exposed, and it's just a pure white sky behind you. That is one of the aspects in which this solves, correct?
And any other situation like that. Windows, if you're in a house and you're taking a real estate photograph and there's a window open and it's daytime, you'll have exactly the same problem. It just, anytime where there are objects that are very different brightnesses. So we started that company. so Steve Jobs got interested in the app. He thought it was really cool. So we were in contact with him, and he's like, I want to maybe buy the app and build it into the iPhone. And we we were talking about how much it should cost, and we mentioned Android, and how do I say it? The deal fell through at that point, and so that didn't happen. And so I had like a day where I was like very excited. I was like, cool, like I might actually sell this to Apple. This is before the Google company. Before I sold that, this was like a year before that. And so I was very excited for one day. Then like it fell through, and I was very sad. And then what actually happened was HDR came out for the iPhone, but it didn't come out for the old phones. And it was extremely marketed really well. And so our app ended up becoming the #1 photography app on the App Store for a while. And we were actually in certain countries the #1 app overall, which was amazing. It was like a $2 app, and like we sold way more copies as a result of that. So the moral of that story is sometimes what seems bad can actually be really good. We actually ended up doing better than we wanted to originally. It took longer, obviously, but we ended up like selling more apps than we like thought we would sell beforehand. So that was a really interesting side adventure.
I think the caveat there is if Steve Jobs is interested in your app in the first place.
It was a really interesting experience. I mean, it was a classic thing where they say, you're a feature, right? And so that was like sort of like that was an interesting, sometimes it can still work out. So that was all before I went to Google. Was a research scientist at Google for a couple of years, worked on AI there. Yeah, and I learned a lot from the people there as well about computer vision and a lot of things and how to do large-scale distributed computing. So I decided to start another company. This time, my goal was really to build an extremely easy way to get started in machine learning or computer science in the cloud. So the idea is that instead of having to install a bunch of stuff on your computer, get it all working, which can often sour the experience, it would be a website where you could literally create a snapshot of a working environment and share it with someone, and then they could just start it up and it would just be running in your browser. The website was called terminal.com, which I got from my dad from the Terminal Exchange Systems that company. So that thread emerged. And it was, the funny thing is it was a terminal in some sense. Like you were just getting access to a machine in the cloud, right? And so it was just using the browser as a terminal. So that's why it was called that. That company, what I ended up doing is the main focus was education, which was one thing I learned is like it was a decent market, but it was not like a huge market, right? But my purpose was really like I was just excited in teaching people. My goal was just to make it easier to learn how to program, and so that company ended up being used by a lot of different education companies. Stanford used it for their deep learning class because you could get a GPU in the cloud really easily. It was sort of like Colab. If you've seen the Google product, colab.research.google.com, it was like that, but before that. And so we started, I built that company. And at some point during it, I realized I was spending a lot of time not doing AI, which is the thing I was actually excited about. I was helping other people do AI, but I myself was not doing any AI or machine learning, right? I was like creating infrastructure to allow it to be good. We sort of we created our own notion of containers where you could, create snapshots of working environments and so on. And ultimately I decided, let me just sell this company and I can go focus on machine learning, which is the thing I was actually passionate about. And so while I was running that company, I'd seen all these advancements in deep learning, and a lot of things that were in my PhD hard to do was now becoming a lot easier to do. So when I was a PhD student, like implementing gradient descent for a complex model was not an easy feat. Like you had to write the gradient yourself by hand, and actually test it. You had to implement, you have to implement all of the things that are now completely automated. So you'd have to, a lot of these modern deep learning packages like PyTorch and TensorFlow, one of the key selling points is auto differentiation. They will automatically, you can just feed it the objective function, right? The thing you want to optimize, and it will calculate the slope and figure out how to, and give that to you. And then you can use that to optimize your model. Back in my PhD, this was you had to write it by hand. It was very difficult and it took a long time. But now it was possible to do all of these things a lot quicker. So basically, I started thinking to myself, I want to do something with AI that will make the world better. And I thought healthcare is something that really could use a lot of improvement. And so I sold the company to Udacity, and I started gestating this new idea of how can I make healthcare better? And a lot of companies had started in like radiology and like clinical stuff. And I thought to myself, like, no one is addressing this other problem. You hear about all these doctors with burnout and all of this administrative work that they have to do, like all of this paperwork. And I thought back to my Google Print days and like, could we automate all of that paperwork? Like, could we have AI just like take care of it so no one has to deal with it? And no patient gets a surprise bill because there's some error that occurs. And that was sort of the idea. Like, that's the company we decided to start with, Akasa. It's like use machine learning and AI to automate all of the boring stuff in healthcare. So doctors and caregivers can focus on delivering care rather than paperwork. And so that's sort of how I got from there to here.
Right.
Wow.
Very cool.
What a journey you've had. That's really cool products and companies and stuff that you've been able to work on, and then just cool people to meet too. That's amazing.
Yeah, I was going to ask who's going to play you in the movie. There are a lot of web developers out there who are curious about AI and machine learning, but to them it's kind of like blockchain. It's a technology that they know and are somewhat familiar with, but haven't actually gotten the chance to understand what it is to actually develop with AI and machine learning. So I'm very curious, can you describe for other developers out there who may not be familiar with what it takes to develop with AI or machine learning, what that kind of process is and what you'd recommend to kind of get up and running within that space?
That's a great question. The first decision to be made is, do you want to build your own models and actually get really deep into it? Or do you want to use AI and machine learning as a technology that you apply to whatever your domain is, right? And based on that decision, I would recommend different approaches. So if it's an application, which is reasonable, there's a lot of things that already are possible and like we can just take advantage of them. I think what you should do is probably get started using PyTorch or TensorFlow, download some models, and run them on some data. I think there are ways to even do this in the cloud. I think there are some Google websites where you can literally just like run a neural network in the cloud on some input data. So I would say, let me restart that. So from that fork of I want to use it as an application, first think about what are all the things you've seen people do with AI. So there's a lot of computer vision stuff, right? Like we can now detect people extremely easily. We can, optical character recognition is like very well solved. We can detect objects really easily and so on. And then there's also audio, right? Like voice recognition is now essentially is a lot better than it used to be and works really well. Basically pick the domain and say, these are all the things. Then there's, those are all the detection and recognition applications. And then there's generation. Like you've seen things like DALL-E or, where they can generate images automatically from typing in sentences and so on. So I would say figure out, look at the applications you've seen people do something with, and then think to yourself, what, if you want to make your own app, think about what cool app could I build that leverages those technologies, right? And then probably find an API that you can just call that turns it into a service or into an easy thing that you can embed into the browser that you can try it out. And so, it also depends if you're doing mobile or web. If it's mobile, there's also a lot of SDKs that Apple has and Google has and so on for running it locally or in the browser. So, or if it's as a service. And I think that's kind of how I would approach it. If you want to learn how to actually do the models, which of course I recommend, because I think it's a lot of the time there's a model that doesn't quite do exactly what you want, but if you can just take it and adapt it to make it solve the problem you're actually interested in, I would recommend taking an online course in deep learning, actually. And a lot of them make it extremely easy. Now, it's, at Udacity, you can just get an instance in the cloud, as part of the course where everything will be set up for you. And you can just start learning. Coursera also has courses.
What a world, man. Take an online course and just get some deep learning instances in the cloud spun up for nothing. That's amazing.
I would say learn how the models work. I think if you're serious about it, I think people underestimate this part, but I think just remember multivariable calculus. If you ever took it, what is the number one thing you need to know is a
just remember that good old multivariable calculus.
Yes. Okay, well, maybe not. You only need the first semester of it. You don't need to know the integral part, just the gradients. Be able to, understand what is a gradient in multiple dimensions. What does that mean? If you can really internalize that, everything else follows almost. It's everything else is just applying that to all of these models that exist. It's a long road. It's not easy. But I think it's a very rewarding road to go down because this technology is only going to become more and more prevalent, right? And so learning it now is probably a good idea, I would say.
Yeah, it's interesting the way you say, like, take one of these, especially ones that, are out there with an easy tutorial and some of these established tools, and then apply it to your scenario. My favorite one that I ever saw, and this was a while back, probably easier to do now, was a guy who went and visited his mother and father, or maybe his grandparents, on a rural farm in Japan, and they had a cucumber farm. And he trained this like AI model to sort the cucumbers as they rolled past and like push the little ones over here and push the big ones over there. And it was just like, it was very simple, but for them, it was like really amazing that, this thing that they did every day where they manually sorted the cucumbers could be automated. So I thought that was kind of a fun one. And like you said, figure out where it fits in your life and use that as a practical way to learn about it. All right, everybody, it is that time of the show. I'm going to shout out the winner of a Lifeboat badge, someone who came on Stack Overflow and saved a question with a negative score, gave it a great answer, and now it has a positive score. Awarded 15 hours ago to John Woo, hopefully same John Woo who directed Face
Yeah,
Off
I bet it's
and
the
other
same one.
amazing action films. Update the row. It's the same guy, right? He's an amazing programmer. Update the row that has the current highest maximum value of one field. How do you do it? John Woo has the answer. All right, everybody, thank you for listening. I am Ben Popper, Director of Content here at Stack Overflow. If you want to send us a question or suggestion, hit us up. It's podcast@Stack Overflow. And if you like the show, why don't you leave us a rating and a review? We're always listening. I got an email just the other day from Ellen. She wanted to say, really enjoyed the episode about flipping the interview questions. Cassidy, you were on that one, right? Maybe Matt too. Flipping the interview questions and interviewing the interviewer. She liked that one. Oh, and no cold open. So another vote for no cold opens. They're not coming back. It's 3-0. No cold opens.
That being said, I've been Cassidy Williams. You can find me at Cassidoo, Cassidoo, on most things. I do developer experience at Remote and OSS Capital.
I'm Matt Kinander. I'm a developer advocate here at Stack Overflow. You can find me online, YouTube, and Twitter at Matt Kander, MattKander.
Hi, I'm Varun Ganapathy, CTO and co-founder at Akasa. We're hiring, so for all sorts of engineering roles. You may have heard of tech freezes. We are not freezing our hiring. We are really looking for people. So if you're looking for a job, please head to akasa.com/jobs. You can find me on LinkedIn. That's probably the primary place that I am. So if you want to message me, feel free to message me there or connect. And thanks for having me on the show.
Yeah, thanks for coming on. It was a fascinating journey you had. All right, everybody. Thank you so much for listening, as always, and we will talk to you soon.